Let's take a look at how you would multiply two different rational expressions together. So here, let's say we had x minus 2 over x plus 1 multiplied by the rational expression x plus 3 times x plus 5. So basically, when you multiply rational expressions, all you really do is you multiply the numerators together and you multiply the denominators together. There is no common denominator or anything like that. If you're multiplying, it's very similar to how you would multiply two numerical fractions. Just multiply the numerators and denominators, and that's it. All right, a few little side notes to add to that though. We need to factor everything first. Before we start multiplying, it's best to see if everything in its factored form. Now, in this small example, that's not necessary. We'll do a video after this one where we do a more legit full example where we'll actually have some of these other details. But these are all just individual factors themselves. But if this numerator right here was a really big polynomial, we would need to factor that first. All right, second of all, what happens quite often is whenever you multiply these two guys, you either before or after, there will be some common factors in the numerator and denominator of some of these expressions. If you have any of those, you can go ahead and cancel those and simplify your answer. All right, and the third thing is leave your answer in factored form. Most instructors want to see this answer completely factored out, not foiled in the numerator and denominator. So just keep that in mind. Unless your instructor wants it foiled for some strange reason, most of the time we prefer to leave all these things factored completely apart. All right, one last thing I want to mention real quick before we end this video. You can actually do what's called cross canceling. Now what does that mean exactly? Well, here I'll show you a quick example. We'll make one up here. Let's say your first expression was a pretty big expression like x plus 3 times x minus 1 over x plus 2 times x minus 5. All right, that expression in and of itself does not have any common factors, that we could cancel or anything like that. But let's say in the other expression that we're going to multiply this guy by, maybe we have x plus 2 times x plus 7 over x minus 1 times x minus 4 or something like that. So both of these individually are simplified, but we can do this thing called cross canceling. Now what does that mean? Well, look here. Do you see how you have an x minus 1 in this numerator and an x minus 1 in the other expression's denominator? You can actually go ahead and cancel these guys. Now you say, really? You're allowed to do that? That doesn't sound right. They're in different fractions. Well, we can, because since we're multiplying these two expressions together, right now they're in different expressions, but in 2 seconds they're going to be together. And so looking a step ahead, we see that this guy will be in the numerator, this guy will be in the denominator of just the single rational expression. So we can cancel them before we multiply, and it makes life a little bit easier. All right, the same thing with this x plus 2 factor right here and this x plus 2 factor. We can go ahead and cancel those as well. And so then we have less to multiply. So you are allowed to cross cancel. So like for this particular exercise, the final answer would be x plus 3 times x plus 7 all divided by x minus 5 times x minus 4. All right, that's simplified. There's no common factors in the numerator and denominator to be canceled. It's a single factor because I've multiplied the numerator and denominator together, and so we're finished with this exercise.